Paul Decarlo, been great friends since we went to U of H together. He had me do my first cake stand, so really memorable kind of person. Do you remember that?
No.
Yeah.
But now you mentioned it, maybe it was at Frontier Fiesta.
It was at Frontier Fiesta. Paul's at Microsoft, and he's had a pretty awesome career, and he does these talks all the time. And for the last 10 years that I've known you, since you've been working there, you've been doing nothing but Demo Fest, and it's awesome. So take it away, Paul.
All right, thanks. Yeah, so Michael, thanks for the introduction. Yeah, my name is Paul Decarlo. I'm a principal cloud advocate at Microsoft. What I work on primarily in my day job is I lead our data advocacy team, so everything that falls under Azure data, which is, if you followed announcements at Build and things like that, the big project that I'm a part of is something called Fabric, which is like a Snowflake, Databricks, all-in-one software as a service, data analysis service. It has so much stuff to talk about that you could talk about it like for a whole year in a user group just to like make a single 100 level tour around all the things. So it's a lot, and I'm always busy with that, but if you ever have any questions or looking for the inside scoop on that platform, I've got it, and I'll give it to you. Would love
What's your number?
Find me on LinkedIn, Paul Decarlo. The platform formerly known as Twitter, PJ Decarlo, you can find me there too. Or you can email me at pdecarlo without the J, because for some reason, at Microsoft.com. You can find me there. So the presentation, if there's something about this that you like, even a slide or whatever, you can get at aka.ms/LLM-on-Jetson. So let's talk a little bit about this. So when I actually originally made this presentation, it was because you can run these LLMs on these small devices, and I'll explain like what we mean by that and what like what the capacity of that implies. And I'll pass this around at some point when we get to that point of the talk, but like a device this size, which is really, really small. And I'm always working on something, or at least I like to, because it distracts me from life, and it's fun to accomplish and solve problems and things like that in your spare time. And so this one, I was overseas for like 6 months. I was in the country of Israel. A lot of what I was doing on the weekends and when I wasn't working was this stuff, which was really cool because it's actually it's like the third largest AI focused country, I guess. So there was a lot of things going around there, and I kind of felt like I was on the wave. I don't know. Have you all ever been to like San Francisco or something like that? Or Silicon Valley? And you're like, man, things just move faster here. I kind of felt like I was in that wave temporarily. Yeah, like really at the top. It was an interesting feeling. So it was cool because I could talk to people who are doing the same things or achieving the same things in person at the user groups there. So this is the first time this talk's come to America, and it's the second time it's ever been given. So the first thing we'll talk about is this concept of large language models, or LLMs, which is at the forefront of this new AI paradigm that we see. And what I'll start with is the way that you can get this accomplished, no matter who you are, what software you have, or hardware you have available to you, so long as you have an Azure subscription and a web browser, and that would be the Azure OpenAI service. Now, what's kind of interesting, if you look at where like the current state of the art is in AI, it is this field we now call generative AI, but it came from stuff far back. If you actually trace this back just to 2017 to deep learning, I would say that's the actual paradigm that has led to this. But going all the way back, with the artificial intelligence was first like computers that could replicate intelligence. And if you think about it in '56, I mean, that's pre-Commodore 64. What do you think AI was like then? It was, probably, memoization, or things returning you results or looking things up. In 1997, look how many years it took before you got to the concept of machine learning, which is where you could start to detect patterns essentially in data and use that to make predictions or decisions and that sort of thing. Then deep learning was really the, Michael, I'm trying to think, I feel like this actually was before 2017, but this is what my slide says, because this is when you started to see neural networks essentially take place. And the way those essentially work is you have all these nodes that are connected to other nodes, okay? And so this is like the super quick 30-second version. And they have things called weights attached to them, which is like the probability that it would go from this thing to this thing based on an activation function, like what goes into it, the likelihood that it'll trigger or light up the things under it. Okay, this is important because when we talk about the scale and why these things are getting so smart these days. So like the concepts were made then, and what you're sort of seeing now, in my opinion anyways, is two things. A movement from what was called recurrent neural networks, which was like the 2017 research when you started seeing computer vision and things like that come out, was a lot based on that. And it's actually really expensive. It doesn't scale very well. What's so interesting is the generative AI stuff, at least on the text side, scales really, really well because it solves a completely different problem. And it does it in a similar way. It still uses a neural net, but it's not using recurrent neural nets. It's using a completely different technique that I failed to test on last week, so I'm not at in any way obligated to talk about that or qualified, I should say. But I will be one day, and I'll come back for another user group for that. So what happened was back in, what was it, March, OpenAI Microsoft had made a deal, it was like a $19 billion deal, essentially to like license this large language model that they had created that all of a sudden was doing things that they called like emergent behaviors, like so it kind of seemed like it was smart. And maybe it is. I find that it lies sometimes, like it hallucinates, it makes things up. But you can actually render that or train that or ground that, keep things honest, if you will. And also there's some techniques, and we'll look at some of the very early ones that came like almost right when this announcement was made, that allow you to trigger subsequent things. And then we'll also look at, well, you know, what if you put all the AIs together? And that's called multimodality. Like I want it to like look at a picture and tell me what it says there, or generate a story about the picture or something like that. That would be multimodal AI. And there's numerous different ways to combine these things. So on this note, you've probably heard about this. So you have GPT 3, 5, and 4 that make up the text generation component. ChatGPT, which is the conversational component. Codex, which can generate code, which is actually surprisingly good at what it does. You know what, something I don't think people talk about enough that I use it for all the time, because I used to call Michael or his friend Zachy or Eric all the time for things like IP table support in Linux. They'll not only tell you, like, you can type in like a command and say, what is this doing? And it's better than the man pages. It'll even look at the context of what actual port is listed there and like tell you. And I like things like that. So I was one of those who kind of like wasn't a believer until you actually start throwing things into this and getting the responses back. It's really interesting.
I was going to say the best thing it does is it writes PowerShell for you really well.
That would be one of many examples. And you're going to see other things too, like DAX query generation, SQL query generation, and that sort of thing. Oh, which is so great, because I always feel, that's weird, I lead the data advocacy team, but I never took a database course in undergrad at high school. I did take the grad courses, so I know a little something about them. But thank goodness these are here, because a lot of times when you're thinking about things like complex joins and stuff like that, the LLM can do that. And I'm the type of person, if I see a query that works, I can make sense of that. Can I go from nothing to something? That's not my skill set. But I like that, and I feel that these can be human-assisted tools. And then of course you have DALL-E 2, which is the image generator, and these things actually I think you're about to see DALL-E 3 right around the corner here. This is interesting because you can prompt it like generate me a picture of blah, and it will just give that to you. And I think this is really interesting, especially when it's interesting and scary, because before we go into an open discussion about this. If you can generate text and you can generate random images, and there's a lot of websites that are focused on like posting images of things and writing some random subtext. So like, I feel like this is bot generation behavior at its worst use case, but at its best use case is what I was telling you, things like being able to ground stuff with, say, industry specific knowledge. Like say you were a law firm and you wanted to blow in all the cases related to some case that you were working on. You could ask the Oracle ChatGPT to come up with some sort of explanation on what you think that outcome is, and it would logically determine that for you. That's one of many different things. So when you look at this, and there's this combination of OpenAI, Microsoft, and let's not leave out the hardware component of this, which is powered by NVIDIA. All of this works because of GPU accelerated hardware underneath the hood. It's not to say that you can't run an LLM on a CPU, but it's like highly not recommended. You're going to get terrible performance compared to a GPU, just because of the vectorized calculations and things that are involved in computing all of those weights. I don't know. Do y'all see that? Like when I draw this out in the air, like do you see that? Like a thing that's just like, doing multiple calculations at the same time. Like that's the real power. So generative AI, like you've seen this, the examples are, for text generation, we can throw it a prompt, and it'll spit things out. And then you can even say things like, to generate an image, generate code, generate some sort of a chat content here. And this is interesting. And this is another thing that I was not a believer of until I saw it done well. They talk about prompt engineering, and I'm thinking to myself, well, asking a good enough question, like how can that be a field of engineering? And it is. It absolutely is. In fact, depending on how you generate these prompts, you can get even what I would call even more amazing results. Like for example, if you check my LinkedIn and you see like the top post that's on there currently, I will admit I did it with the help of Azure OpenAI. And it looks beautiful. It has like one emoji per line. And that's because someone I work with had generated this query that was like, oh, are you gonna like do something for social media? Try grounding your article here and then feed it into this thing. Like it reads your blog post and then it will generate what sounds like a Twitter release thread with an emoji on each line. And I got way more engagement than I ever have. And I struggle to pick the right emoji because I'm a technical person. So I'm not saying that's why, but I just don't. I'm not very good with emojis. Okay, let's just say that. Where these things are currently in Azure, GPT 3.5. I also want to say ChatGPT might actually be out of preview. GPT-4 is in preview, and I did just get access to that last week, so we'll kick the tires on that a little bit. But these are just large pre-trained models that use deep learning to produce textual output. And that's a small sentence that can be extracted to say a lot of things, and I'll try to say as many of those as we get in the next slides. Custom tunable AI models. This is one of the things that Microsoft makes interesting too with their platform, is that if you wanted to use large amounts of, voluminous amounts of data that's specific to your organization to essentially tune the model. We're not going to say retrain, because to retrain is a bit more complex, but you can tune the AI model to give you better results. And built-in responsible AI to detect and mitigate harmful use.
So is that adding parameters and training those parameters, or is it like
there's a couple techniques, and I don't know which we make available via a service yet today. I know we do a service with Azure Search where you go in and you essentially take chunks of tokens out of the document and turn them into a vectorized database, and you're essentially kind of like memoization, I guess is how that sort of works. There's also things too like RAG, which is a different technique that actually does train the top layers of the model. It doesn't go all the way through, so it's a smaller part. And there's also something also called low rank adaptation, or LoRa, that does something similar to that. So first thing we'll look at is, what does this look like in Azure, this Azure OpenAI Playground. So I should be logged into my Azure account. Here we go. I'll sort of show you what this looks like, at least from the start to fin. So you do have a new deployable service called Azure OpenAI. And one way to think about this, just to give you some familiarity, is if you have used ChatGPT, it's like your own ChatGPT in a private instance that only you can access, and your data is never going anywhere. It is a known fact, and shouldn't be too surprising, that ChatGPT does use public queries and things like that to generate knowledge on how they should potentially train their future iterations of their model, which I don't think is a bad idea. I mean, it is a privacy concern, but I don't think it's a especially if you're using it for free, you should understand that there's probably some costs involved there. They do use that data, and in this case, you would have a private, essentially secure, so if you're using proprietary business information and that sort of thing, you can do that. And inside of here, I'll show you the latest, the GPT-4 sandbox, and this is not available in all regions at this point, just because it's in preview, and they're lighting up every day. But if you come down here to model deployments, it's very easy. You would create one of these instances, and it looks just like that. You come down to model deployments. I don't even think I read the docs on this. I just think I luckily clicked in the right 3-4 places. It was that easy to use. Then you can click over here to create deployment and choose essentially from the flavors of models that are here. We do see today already models will get deprecated and then a new one will come out, and that can create some bit of a life cycle sort of issues depending on if you're using the latest and greatest, will it stick around? I'd say it's normalizing now. You have to understand this was like a service that Microsoft really rushed out the door whenever that announcement was made with Azure OpenAI. So they took everything that it had. They've realized, some of those things might be better than others, and they're sort of giving you the best of the best today. So you can choose these models, and then once you have a model deployed, it's very easy to go ahead and jump in and start playing with it. If you wanted to, you can jump in, start to, if it's a chat-based model, you can walk right into the chat. This is interesting, and you probably know this, but if not, you have the system message, which essentially is like it will affect all subsequent queries, essentially is what that is. So if we want to say like, you're an AI assistant that helps people find information, it'll be pretty general in its behavior, but we could do something like, you're an AI assistant that, talks like a pirate, and not saying this is useful, but, and helps people find information. And if I did that and then started to generate new prompts based on that modification, it will likely, so we'll update the system message here. Let's just, type hi, just to see kind of what we get here. See, ahoy there, matey. How can this old sea dog assist you on your quest for knowledge today? That's all it took. But you can start to think about this when you're starting to create like intelligent assistants. You can tell it things like, you're an airline booking agent who, doesn't leave people on hold, and it might behave in the way that you sort of describe it, and that's very easy to go through with this. Now, of course, you could assume, like, we've got this service, and you can do this, but how do we scale this and actually build production grade tools and things like that from this? Is of course the fact that these things have an API that can be called. That I have some critiques about, and I cannot wait to share them with you because they're fun. So that's Azure OpenAI in a nutshell, and some of the things that I guess that won't be a shocker to you, like, because I feel like when people see this, it depends on who's in the room, but like, a child might go, that's just ChatGPT. There was nothing different about that. Well, except that your data is your data this time, and your data is not ever reused, and you can, to some extent, customize the output here, and your data is protected by the most comprehensive enterprise compliance and security controls. Boy, I like that, the way that sounds. But that's the whole point here, right? It's like you can't just walk into an organization and say like, hey, here's your OpenAI key, like go to town. That might not be the best idea unless you're paying for their enterprise service, and you get something similar to this, but on the Azure side, you get this, plus you're gonna get the integrations. And where the integrations come in, become really, really interesting, and hopefully we'll see more of this probably as we get closer to Ignite. These are the things that are going to power what they call the co-pilot assistants that you're going to start seeing. You will see LLM-powered assistants in your operating system. And I'm pretty sure my OS at home that runs on my personal desktop is not a Microsoft corporate image. And I wish I could show you because it has some of those features of greenlit in it. Is anyone else having that at home? It just happened last week. It just showed up. I have this co-pilot.
Yeah, they launched the update last week.
Copilot for Office, right?
And there's a co-pilot in Windows too itself, where you can be like, change the brightness or whatever, and it'll just automatically open settings and show you where to go and do it.
They're integrating all the services pretty much.
It's interesting, and it's an interesting paradigm, because if you think about it, like, what are we really doing here? We're building. It's like I think about, like, what do you do when you sit down and go to a computer for work? I'm sure a lot of people are like me. You open Outlook and you start searching and scanning through emails, and then you go to the internet and you start searching and scanning for stuff. It feels like it's almost like a browser style interface, but it's an LLM talking to you, but it knows things that it can do in your desktop environment. Does that make sense? So it's like a different portal and a different way of working and interacting with things. You can even ask it to generate PowerShell queries for you right then and there. And that's interesting, because it makes you wonder, like, how does this work, and how will all this stuff work? And we're going to explore some of that here today, because imagine that everything that you're doing and asking to this service is somehow making a cloud call to some web-hosted API. That doesn't work when you don't have the internet. And I'm not sure that you need the internet for these things to work in a very, very startlingly powerful capacity. And that's what we're going to sort of explore here. So you have this concept of things called foundational models, and these are models that can essentially work with different types of trained data to produce different adaptable tasks, if you think about that. So a foundational model, and in this case, it's saying it's a transformer-based model. Typically, when you hear transformer, that is in the realm of large language models. It's a encoder-decoder style model that essentially picks through. It's actually generating a word at a time and determining the probability of the next one by working with billions of input parameters, which we'll talk about the size of it in a moment too, because that gets crazy. But you can sort of see here, like, if I had a foundational model that was a transformer, meaning that it works with text, I could do things like question and answer, easy, tell me who was the first president of the U.S., etc. Sentiment analysis, what is the general feeling or emotion expressed in this text? Information extraction, if you're using specialized data where you're grounding things. Image captioning, object recognition, instruction follow, code generation, code understanding. Now these ones are interesting here because those are not text-based. Those would probably be a image-based input. And as you know, some of these GPT models are what we would call multimodal, in that they can take different inputs and produce different types of outputs. When I say different, I mean like they're not just text-based or they're not just image-based. There's some sort of combination of the two. And it's interesting to think about the direction these models are going, because how should we accomplish this? Should we make a model that's good at everything? Or should we make one model that's good at vision and one that's good at text and somehow combine the two? And if we combine them, how do we do that? Do we actually want to splice the networks together, or do we want to make them two completely separate things that just pass external responses to each other? Those are architectural and design questions that have a lot to do with what actually builds these things at the end of the day. So these foundation models and what the history of them is. So the popular one that sort of emerged on the scene in 2018 was BERTS, which is a transformer-based, think of it like an early, it is an LLM, but an early base. And it is a 340 million input parameter model. And by the way, each one of these that I show, and as we see the scale grow, was the state of the art at the time. So keep that number in mind, because this will kind of blow your mind when we get closer. So 5 years ago, the state of the art was a 340 M. And you're also going to notice it's not like, it's interesting and promising, and we'll see on the next slide, because you'll see like how exactly are these things getting more and more powerful? Well, you're going to notice that number just keeps going up. It's basically we're using more compute, using more hardware, we're using better, most efficient GPUs that are on the market, et cetera, to produce these. So in 2020, Project Turing was the state of the art. So this was a large language model, essentially built only 3 years ago, that runs on 17 billion parameters. Now, this was like probably not accessible to you and I. This is going to blow your mind, because like I'm spoiled with surprise. 20 billion or 17 billion billion input models can run on a device like this, on a device this size. In fact, 33B can run here. Not recommended. It's like 3 tokens per second, but it does work. So now you see where this starts to get. Well, how did we get to where we are today? Of course, OpenAI appears on the scene and goes like 10 orders of magnitude higher to 175 billion, also in 2020. But see the trick here, all that they did, I'm not going to say all they did. There might be some subtle modifications to the underlying network architecture. But the big thing is the number of parameters that they're using now to train this thing. As that number gets higher, these models get smarter. That's like all you need to know, really. And then you have where the things are today. GPT-4 is a 400 billion input parameter model, and the state of the art, 2 years ago anyways, which we're about to eclipse, was Megatron Turing, which was 530 billion. So you need to understand, that's interesting to me. I don't know what to take from this, and there's obviously some architectural differences in the underlying model. So GPT-4 could very well produce better results than the 530B Megatron could. I don't know, I've never used Megatron. But notice this, though, is that like this thing that was definitely not accessible to the public, we pretty much have that now. And it begs the question, what do they have that they're not telling us about? 1 trillion input model. So, you can start to look at these things and you start to think, where I saw these when I first worked with these is my AI background came from object detection, which I just thought was the coolest, most amazing, super cool thing. And in that world, essentially, you get better results with varied input of training images, meaning like whatever the thing is you're interested in, get a lot of images and get a lot of variations of them. Because you want to avoid 2 things. You want to avoid overlearning, which is like if I give it too many images that look like exactly the same, it's gonna not really know how to deal with images that look different. Image taken in the dark, image taken on another angle, etc. If I give it a bunch of variations, like images with different colors, different taken in the dark, different sizes, etc., like that, it starts to become pretty generalized and pretty adaptable at that point. Now, for me, I've always thought that was a magical technology, and when I looked at this text generation stuff, I'll be honest, I couldn't see it. I couldn't see it. I was like, I felt like we were taking a step in a different direction. I'm like, the vision stuff's so cool though, because that's like seeing, it's like TV. Texting's like a typewriter. But of course, the itch that would obviously come there is like, well, what if you like combine these things? And so that's where you get to this multimodal visual and text models, which some of these are, I would say, are exploratory and demoware. Some of the stuff I'll show today, or research-based. And definitely where this is going with things like Lava, which you might maybe heard of, which is a vision-based. That's actually an interesting one. You show it an image and it spits out text about the image instead of, and you can tell crazy things like write a story about this and show it a picture of a comic book or something like that, and all of a sudden you've written next month's issue. Like it's pretty crazy in that way. So, and of course, as you can see how these things would work is you have your corpus of data, which could be image and or text, and we would produce essentially different results based on our models, which could be either a foundational model that's capable of working with both inputs and generating both types of outputs, or as we'll see, you could also do things like identify what somebody's trying to do and maybe call a completely different model. Because remember, there's nothing wrong with the computer vision models that came out in the last 5 years. What if we had an LLM that we could talk to and then it could choose to go do something with an image that we have and work with it? So that will be one of our first demos. So you can see things too, like, and this is also where things like text to image, the stuff you see in DALL-E was born, where you can say things like, give me a mountain with clouds and just boom, just generate a mountain nobody's ever seen before. On the image to video stuff. And what I found really interesting on this is the way to generate this isn't, I'm not saying I could have done it as a homework assignment, but it's not that big of a leap technologically to go from I can generate an image or a frame to I can generate a video. And you can do this. The demo I have usually breaks when I try to do this, but sometimes it does work. So we'll get there when we get there. So the last thing too, before we look at some demos, is the prompt engineering concept, which is, like I said, I didn't pay a lot of attention to this. I just thought, I'll just, tell the thing what I want to do or ask the question I want to get an answer. When you start getting really creative and you tell it like how you want it to answer and what you want it to do or not do. Like one of the things I find with these LLMs, when you start to talk to them, that gets very annoying. And you may not have ever spoken to an LLM, and we'll do that today too. But it gets really annoying as it starts giving you these lists, like 1, 2, 3, 4, 5, 6, 7, 8, 9, which is great when you're reading. But when you're trying to talk to it, so you might tell it something like, don't ever give me a numbered list, and it won't do that, right? Like, it's little simple things like that. And also, prompt engineering has a way more power to it if you start to think about it even more abstractly, as in, I want to identify a task that I should perform. So like, tell me how many zebras are in this picture is a good example of that. It should be able to understand that you mean to take this picture, which is either encoded in a URL or some file path, and you want to run a secondary model on it that's like, either specialized or if it's a foundational model that uses the visual component to generate the result. Now, what's interesting about this is where all this stuff is happening, where all these models are happening. Hugging Face is the place, this is the Wild West, if I was to say, of AI models. And there's so many of them. This number is larger, because I haven't updated this slide in months, but sure, a lot of people, I think not enough people like it personally. And they had, a few months ago, over 230,000 models. This gets crazy, by the way. And if we get into some of the community discussion, like where's the hacking and all that sort of stuff happening with this stuff, what I mean by that is like, where's the fun, like people experimenting at home things. Models are getting uploaded every day, converted to various different formats, and utilizing various different techniques that allow them to run on various different types of hardware, et cetera, et cetera. So for me, Hugging Face is kind of like the supermarket for AI models, just straight up, it is. And what's really interesting too is how do you achieve acceleration of these models? So like, because that would be the hard part, right? You think about this, or at least if I was a traditional programmer and I was like, I don't want to get into this AI stuff, I think it's too hard, it's too complex. Sure, that you could think that, but it's not, because the way most of this works anyways is you have two libraries, PyTorch Audio and PyTorch Vision, that essentially most of these models in some way are leveraging, and that just gives you the acceleration out the box because of what they're using. And if those things get extended to add support for a new technique, you don't have to be a scientist to play with that kind of power. But if you were a scientist, then you could really do a lot of damage. And not to say that, I think these things are way more accessible than you think. So if you wanted to take some of those down, we'll definitely say check that out. So we're going to look at a project here called Jarvis that was a combination of using OpenAI, NVIDIA accelerated hardware, essentially to do what I was just describing. This is what this really was, is a prompt engineering research activity, if you want to think about it like that, to where can I identify the task that someone wants to perform to call a series of different models that are available on a device. When they created this, things like LangChain or semantic kernel, which are libraries that help you do exactly that, this like task identification and things like that, didn't really exist. So they kind of rolled their own into this software. But I would challenge anybody out there, if you wanted to build something like this and maybe take some of the more modern frameworks, that'd be a cool research project. It might not be that difficult. And what they achieved here because of Hugging Face's versatility is what you really have at your disposal if you write the right task processor is I can interface with an LLM, ask it anything. It's basically unbridled except for the responsibility and not being dangerous aspect of it, which is of course very important. But I can now call into any model that does any type of task that's available on my device. So you can do things like, I'm going to give you an image of a boy, and I want you to change it to an image of a girl reading a book. And so the way it's going to do this is like, it will look at the image of the boy, it will run open pose estimation, and you can see here sort of drawing the skeleton. We'll then call something like stable diffusion, which will use that bone map, so it knows that see the heads here, and you can see the heads here, and the arms are here, head, arms, and it's filled that in with a person, and it's given them a book now, essentially. Now, why would you do this? I don't know. I haven't thought of the business case because I don't care about the tech side of this, but there's probably a business use case here. And we'll play with this to see what maybe some of those are, because we'll do whatever we want with this. So this is called Jarvis. If you type Microsoft Jarvis in, it should bring you to a GitHub page, it'll have it. Now, where my claim to fame is on this project, I added the support to run on the NVIDIA hardware. I will tell you that running it in full mode on the NVIDIA hardware isn't always stable. Even with a 64 gig RAM device, it can experience out of memory errors. And where we're running this today, just because I have another device at home, and these are expensive, so I only have one. It's actually running on a desktop right now. It's a little more stable for some things, it's unstable in other areas. But this is an unstable demo. I will warn
Is
you.
that 64 gigs of VRAM or?
So the architecture for these IoT devices is interesting. The system RAM is attached to the GPU bus. So it is 64 gigs of VRAM. That's also RAM for everything else on your machine. Which is really wild because you're hitting something very interesting when you said that. Like the 3080, which is like the affordable graphics card that isn't exactly that old, is 10 gigs of RAM attached onto the bus. So funny that you said that because this device actually can do more than the desktop with a single 3080 can because it has more VRAM essentially. And the other aspect, which really starts to beg the question too, like why are we selling graphics cards with RAM built into them when we could? There is architectures that allow you to do. Now I think this might actually be a consequence of it being small.
It might be a bus bandwidth sort of thing.
That's my guess. But that's interesting. And the other thing that's interesting too is all those models we were showing the concentric circles getting larger and larger and larger. That's orders of magnitude of memory. And I can just give you off my head, I want to say like a 13 billion input model is like 20 gigs of RAM. So you try running Llama on a 3080, Llama 2 13B model, it may not run as well as it would do on a IoT powered or sized device that happens to have more VRAM. Now, of course, you can look at this the other way and then say, well, cloud scale architecture that has things with hundreds of gigs of VRAM blows them all away. But they're not in your house. They're not, small, and they probably produce a lot more power consumption than the smaller devices. So this is Jarvis, and the way it works, just to give you the architecture without going into too much details, but just tell you like how it works. There's a few components to it, and it's not going to surprise you, and I can go into details on any of them that we want before we show the demo, but what it essentially does, it runs a model server. So a thing that takes a bunch of models from Hugging Face. You have to download those up front, which is 100 or 80 gigs of memory just for the models, and it'll instantiate them as you call them. So that's why this demo is a little flimsy, because like the more we use it, the more likely it is to tip over. And I can't bring it back, by the way, if it dies. So, and it will die. We'll use it until it dies. I'm confident of that. And then there's a chat server program that's ran against that, which basically parses input to a third piece. So like these would be those first two pieces. So the model server, which is basically like the clear-cut word that might not be recognizable to everybody is it's an inference server. It like knows what model to pick up and use for a set of inputs. Chat.py, this server, what that's doing is looking at the textual input, and then it's determining the task. So then it's determining what model. And then the third part is the web interface, which we're calling Hugging GPT, even though the project is called Jarvis. So we can do things, and they give you some examples here. I think it's fun to like, try to kick it over and see what we can do with it. But we'll grab a few examples here. So like the first one, it may not give us the right answer for this one, but I do think this is an interesting one to try. Given a collection of images, tell me how many zebras are in these pictures. Boy, I hope this is working. Cool. All right, so it's like thinking. So it's actually taking all those images, calling the model server, determine the task is you probably want to run some sort of object detection algorithm. It has multiple ones too, so it might choose Facebook ResNet, it might choose some other thing, and then it's going to spit something out like request failed with status code 500. That wasn't expected, but what it should do is something along the lines of, I was expecting that demo to die today, so that's okay. It should have given us something along the lines of, it'll tell us, sure, I can do that for you. Here's your request. I've used Facebook DTR ResNet model, which is an end-to-end object detection model with the ResNet backbone. For image A, this is a cat sitting in front of a window. Here's the prediction scores for that. For image B, there's definitely some zebras in that picture. I think there's 3. Here's the bounding boxes, etc. And it'll spit the result back out to you. This is running on a desktop right now at my home, and for whatever reason it just died. But yeah, I do promise you, it runs on the Jetson device, and there is an article I've written about this on Hackster.io. And you'll see here, if I don't have a demo, I at least have a backup here. So this is like taking a group of people with a URL-based image and saying turn them into Ninja Turtles. You'll see it draws the bone structure there. Here's one, generate a video of Darth Vader riding a surfboard. And it just out of nowhere, it just makes Darth Vader riding a surfboard. And then count the zebras in this picture, and it spits that back out, and of course with the bounding boxes. So that's your multimodal AI. This is a way to do it. The reason why I say this is likely research work is because it's attached to a research paper and it hasn't been updated in really 6 months, because the last 2 updates were me adding NVIDIA Jetson support and a few updates to the README. So it hasn't really been touched in 6 months. But I wouldn't be surprised if this isn't being turned into something. You think about this strategy and what you can do with this. It's interesting. So we'll move on to the next interesting, fun stuff. So I keep on hitting at this. You can run these things on an IoT device. Now, the one I recommend, this is actually an AGX Xavier, and the only reason I brought it is because it looks like the Orin, but it's like not as powerful. Okay, it's still insanely powerful. It's just not as powerful. I think this is like a 16 gigs of RAM, some crazy amount of tops. I need to double check before I try to draw that out of my head here. But the AGX Orin is the Cadillac model, and that's the one sitting at home that we're going to do our next demos on, which is 275 tops with int 8 quantized models. About a $2,000 price tag. You can get cheaper if you're an educator, like $1,600 or something like that. But it's crazy to me because it also gave me another vision of the future when I had that thing sitting next to my desktop. Because like, why would I run an LLM on the same hardware that's running my OS and all the other processes that go there, when I could have this like sidecar device that just does all this stuff? And I think what you're going to be impressed about is the performance of that sidecar device. What's interesting too, it comes in a 64 and 32 gig model. You can also get them in these smaller form factor, I guess like even smaller embedded designs that aren't like on a full dev breakout board with the cooling system and all that sort of stuff. So how do you build applications for this? I love the strategy that you take for this. This is cool. So NVIDIA, and they've been doing this for a while now, at least 4 or 5 years, decided to come up with this. It's funny, like NVIDIA drivers. I'm sorry, like on Windows they're cool because they work. Like, they always work. But NVIDIA drivers on Linux, That might actually be why our demo right there didn't work. I don't know, three or four times today, I kernel panicked because some driver issue. Okay, and let's not even, okay, I'm picking on him at that point, but let's go more to the technical side of this, which is like, you ship something that's built against a certain library of CUDA, how the heck do you ensure that that's going to run on your end user's machine? And the answer, which is the answer to every why doesn't it work on my machine, is they put this stuff inside a Docker. But they did it in a clever way. They're kind of leveraging the volume mount feature within Docker. And what they do is the CUDA driver is actually part of your host OS. And what they did, they forked Docker and created something called NVIDIA Docker. Now, that was the old strategy. Now you have Docker, but it has the NVIDIA runtime. And what the NVIDIA runtime does is when you spin up a GPU-capable workload, you throw out the flag GPU enabled, etc., it will mount the drivers that are installed on the host system so it works. And then it builds around that, essentially, the accelerated application. So, which is cool too, because if you're putting multiple applications on a single device, of course you get the benefit of Docker sharing the image layers and that sort of thing. But I like this. And one of the other things I love about it too, at least for an IoT demo, it usually works because it's Docker, right? Like it's my demo worked when I left the house. It should be working right now as long as Comcast is playing nicely. And they have a nice catalog of containers. And one of the things you'll see here too that makes this easy is one of the images they released is an L4T PyTorch base, because this is what would destroy you on a embedded device development, which is compiling PyTorch Vision and PyTorch Audio yourself to run said Hugging Face models, but you just get it built for you in a container. So it's way less time. The time it takes to download it basically versus the long minutes, potentially hours to build, depending on the device and the hardware you have. So you've heard of Llama.
Quick question.
Yeah.
Does that have to run on Docker, or can you run it on like K3s or?
They actually have a Kubernetes deployment that deploys these kind of containers, and there's nothing that was ever limiting you from running on those anyways, because as long as it's in a container. The only thing that was weird, just from having done this a long time ago, was the GPU flag support wasn't as simple as it is today, but I'll just answer your question by saying it's easier today. And you can do things like slice the GPU to different workloads and things like that. So, the Llama, you've heard about this. This is the AI model that comes from Facebook. And I should open this up because this is where I got it. I don't know how this found me. This is this Reddit group called Local Llama, where this is where all the cowboy country stuff is happening. Okay, like if you're like, well, I want to get into this, what I'm about to show you, and like, well, how do I? This Reddit group, you come on here every day and there's a new model. Now, I will say on video, I don't know the efficacy or the science or the quality of some of the stuff that gets released on here, because like every day it's like, oh, we released this new model that has like almost the same power of GPT-3.5. It's like, maybe it does, maybe it depends on how you're testing it, I'm not sure. I'll just say I'm skeptical. But there's some really interesting and magical things that do appear on here. And what you see a lot of people wanting to do, I find interesting in this forum anyways, is getting these things running on the MacBook Atom architecture or ARM architecture. And they do have it running, so it does work there too, if you have a MacBook, one of the latest and greatest. So this is also caught up in a...
Would it be faster because it's VRAM versus PC?
They get some level of performance there, and is it taking advantage of? I don't know the architecture of the new Mac. I just know they talk about it all the time. So I'm not good with that. I don't. Not because it has nothing to do with me. I'm not good with the Mac OS. I'm one of those people.
Yes, slow is fine.
Yeah.
It's slow enough.
So I'm not like the expert. I don't know. And the hardware, I'm not sure. But I know that like it's that new silicon. They've essentially created something that runs there. So this is seeing one of these LLMs run here. And I want to show you just what some of the state of the art looks like. So this is me logged into a device at home that's running some models, and this is using an interface. People will sometimes refer to this as Uba Booga, but the real name is Text Generation Web UI. This is a pretty interesting application, and I will warn you, if you're like a hobbyist and you just get this up and running on one of these tiny devices, there's a lot of rabbit holes that you can go down as just for fun or whatever. Try this model of the day or whatever. So I really, really recommend that. It to me is kind of like the de facto model tester tool, because you can run these models in a number of different ways. If you pull down Llama, the way Facebook wants to run it is with their Llama executor. Then you have somebody that ported that to C++. So there's llama.cpp, which is a command line based engine. And then you have all these other ones. Hugging Face has a transformers engine, etc. You see, I said all those things, but you don't need to know those things when you use the web UI because they're all here. You can choose the different model loader you want. Transformers, XLlama, HF, XLlama v2, etc., or GPTQ. This stuff changes all the time. So like as of last week, what I'm pretty convinced of, Llama CPP is always the fastest. And the type of models are these GGUF, which I didn't know about these until like a week ago. Now, where do you get these models from? You get them from Hugging Face. And this is what's really fun about this, is like, say I want to go grab a 13B model. I can go to Hugging Face. You can just copy the name of the model here, go into this UI, type the name of the model, get the file list, and then determine. They'll usually come in these multiple quantized formats. Quantization is like they shrink the precision of the weights. So remember, those networks have weights. So it takes more memory to store a floating point 16. They'll do things like get them down to 4 bytes or that sort of thing. You'll see here different versions. The naming scheme is terrible. QT_K_L. Those are different quantization methods that you have to go to this table to sort of look up. But what I find people usually use is Q4_0 is kind of like the default. So if I was to type that here, by the way, I've already downloaded this model, but you type that in here, that's going to get you the new model, and you're ready to go to the races with it. Then from there, you can start to tweak things like how much of this do you want to offload to the GPU, what's the size of the context that you want it to have, or ability to remember previous responses, how many CPU threads do you want, and then in batch, which I'm not sure what that does, but we turn it up all the way because it gives you more performance. You can also, in this tool, what's really nice, because you'd asked about training the top layers, you can train LoRa's in this tool, and you can apply LoRa's to models. I've never done it. Sounds cool. In fact, the idea that I would have for this, that would be really, really neat. It makes you wonder, why is Facebook making LLMs? If you have data about a person, you can train those top layers of that model to probably really, really know that person, is my guess. Okay, at least where we're at in the state of this, it's certainly an achievable possibility. Or I like the idea too of like, if you just had a list somewhere of every movie that you watched, and you told an LLM like what movies you watched, it could probably tell you what movies you should watch. So inside of here, once you've selected a model, and I've got 3 of these ready to go, oddly enough, it can run a 70B model. It's slow, but it will do it. And then I have 2 of these, this 13B and this one where I guess they got me with the advertising saying like, this is the one that's like almost as good as GPT-3.5. That's called, well, and they have these hilarious names too. Like every time they add like a new thing to it, the name gets longer. So this is Speechless Llama 2 Hermes Orca Platypus Wizard LLM 13B King 4. So that means it took the things from Speechless, from Llama 2, from Hermes, Orca, etc., and spliced them all together.
Wasn't Blizzard the one that they tried to remove the blockers so you can ask?
Oh yeah, you'll see sometimes they'll have uncensored in them, which basically means they remove the responsible AI guidelines. They're totally would not recommend those, especially for demoware. But you can go in, I usually use the default tab here. And what's nice here, you can choose the system prompt. This is another, like I said, if you're like not staying, this stuff changes all the time. And there's a lot of tribal knowledge, and if you know, you know, you know, you don't know. it needs to have this specific type of system prompt in order for you to do things. And I don't know why. I always test my models with summarize the first Indiana Jones movie. Because I thought Devlin would be here and that would upset him that I didn't choose Star Wars. But this is a model, it's running 13 billion inputs, and you can see how fast it's spitting out that result. It's rather accurate. We can tune things here too. We can do things like tweak the parameters. In this case, we're only giving the max new tokens of 200. Again, tribal knowledge here. Llama 2 models can only max generate 2,048 tokens. Llama 1 models can do 4096, which is weird. I don't know why that went down, but it did. So once you change that, if you start talking to it, it can, see it actually cut off there. But if I ask it to regenerate now, it'll give us even more text, more results. All of these things end up to be tunable parameters. So if you're working on a project or an implementation with a client, you've got to think about this stuff, like how much text should I be giving back? What should be the range? Should I intercept certain things to make some responses longer than others, etc.? Now, one of the, oh yeah, go ahead.
Is it running IoT or on?
Yeah, at home. It's at home though. The device is in my house. I just don't want to unplug everything. I use this. It's as one of my buddies at NVIDIA said, it's my friend. And I'm like, I'd like to talk to it. And it'll answer crazy things. I mean, like, you know, like anything. I'll say anything. Like you can ask it, you know, you're like not feeling well. You should probably go to a doctor, but like you can also talk to your LLM. You can, you know, you can ask things like that. You can ask it how to fix stuff around your house. You can ask it technical questions, and sometimes it answers it.
You have like a multi-year Discord server you've been a part of. You can feed these models the entire chat history, and it's scary.
Like the technical knowledge happening back and forth in online chat room.
Yeah, you can like have it emulate people in your Discord server.
You know what I think is going on? This is all recorded. I think that like a lot of sites like Reddit and stuff like that are probably being scraped for training for some of these. It just feels like it.
Well, web text.
Nobody ever says that, but like I'm pretty sure it does.
You look at
Why
web
do
text
you have ones that
too.
are subscription model?
Because they probably realize they have the old. They're like that's the thing. The input for a text output model is text. What do we have more than anything of on the internet? Text.
Google web text too.
Web text too?
Yeah,
You mean Bing it?
or being it. My bad. I don't know if you'll find it though.
This one?
Yeah. So this
You get paid every time you say that?
this is a pre-training text set that has all Reddit threads from 2005 to 2020.
Oh, so it does. So the answer is
With more than like 5 upvotes or 3 upvotes. There
I've
is.
just asked it questions about
Yeah.
very obscure video games that probably don't get talked about in places. Some of the responses, I'm like, I feel like this answer is coming from Reddit because that's how they feel about this too.
Well, and
You know?
people surmise that this is part of the training in ChatGPT.
Interesting. We get closer to so you've seen this. Now I'll take it a step further. Where they get into some interesting things, and what this tool does is it has this chat style interface where it's almost like you're chatting with an entity. What's the word for this? I don't know. I don't know how to say that. Why am I not getting a response back there? It's not really a demo fail because you're not going to see much different than what we saw before, but like a different user interface. I say like, hi, should get a hi across the screen. Oh, I know why. This new version of text generation web UI, you have to choose the assistant or the example that it comes with. I just want to say that I didn't choose that. That is just what comes here. I just feel like that could give the wrong idea there, but you can choose an assistant. I think we have to choose this assistant. I think we do. And then we can have it speak to us. And what's interesting, there's all these extensions. So, by the way, so this model and the way that it's talking to you, and this is the default. It's part of the parameters. Here, if you click on character, the basic version of this it ships with this, with like a context and a greeting and an image for the character. So we could change this, and you can create some sort of an entity essentially that you can speak with. That's interesting. And there's also these extensions here too, where you can, and I don't know why, but like if you want to make it look like Facebook Messenger, you can do that. You see it's like sort of changed the way that this looks. You can also make it look like, WhatsApp. I don't know why it's not actually changing, but maybe it has to stop talking. Yeah, it's definitely not a parallel threaded program, but I think it's fascinating. And you can just, yeah, there's the one that looks like WhatsApp. So you can ask it whatever, you know, it's you see, but you see how this is different than this? This is like the raw, you know, speaking with the model, but we can actually start to add character and color and, you know, some personalization to the conversation here, going beyond the system prompts that we saw earlier. Not saying that you can't achieve that same thing doing some clever tricks, but this makes it way more, how can I say, like personalized. So that's interesting. Now, you can tell here, and where you'll get some really good ideas here. If you click on session, you'll see all the extensions that this tool has. It has an API. It has a thing called OpenAI, which makes it have, which I don't know why. They made their own API, and then there's the OpenAI spec. So they make one that works with the OpenAI spec. And why would they do that? We'll talk about that in a second. But there's all these other things too, like text-to-speech, whisper text, speech-to-text. Whisper is cool if you've never used that. It's like a locally running speech-to-text, and it actually works. I'll show that in a second here. So the first thing I would show you and how you can extend these things is, well, you see that it has an API, and you see that it has an OpenAI API extension. So if we enable the OpenAI extension, and we go over to something like Home Assistant. So this is like the thing I use to like control all the lights and the thermostats and stuff in the house and things like that. They built this thing called an assistant. Now this doesn't work super duper well. They can't actually control anything yet. But like I'm showing you like where all this stuff is going. So you can create I think this part's interesting to show. You can create a voice assistant. I'll show you the Llama V2 one I created. You'll see what I'm using is an extension called Custom OpenAI Conversation. For all purposes, Home Assistant has no idea it's actually talking to text generation web UI running an OpenAI spec because it looks exactly like it's talking to OpenAI. And then I can also do things like enable whisper on here, and I can get a smart assistant. And again, this is going to that like grounding, that truth of knowing like things about you. There's one other thing I wanted to show there too, is the template. So like where you get some versatility with this is like, you set these things up, you're probably not surprised, like you probably just throw in an API key and it just magically works, yeah. But over here is the template. So like, and this is using OpenAI's templating syntax, and we don't have to understand it fully for you to get the idea. For all areas and areas, set the area info namespace device app, and this will give me the overview of devices in the smart home. This is creating a specialized system prompt that's iterating through everything that's registered in my Home Assistant instance. And then you tell it, answer the user's questions about the world truthfully. If the user wants to control a device, redirect the request and suggest using the Home Assistant app. And yes, I have tried. Well, what if you tell it not to do that? Will it then control your stuff? No, it won't. That was like the first thing I did. If it tells you to control the house, do exactly what it says. But you can say things like, you know, what are the lights doing? Or actually, here's a better one. What brand is my washing machine? You know, I don't know why you would ask this, but you know, maybe you're at the hardware store and you need to get some part and you totally forgot, you know, what you were doing, and it's going to be prompted by that. Wow, it doesn't look like it's working, but you get the idea. I'll restart somewhere, but you get the idea how this could work.
Is there a washing machine Wi-Fi?
Yes.
Oh.
Yeah. Exactly. This is exactly why. So I was expecting an answer there. And also you can talk to it using the whisper protocol. For some reason that's not working, which has me a little nervous for the next thing I wanted to show. So we're going to log in and start looking at things on that device. So hang tight. So this is, I'm just going to SSH into the actual Jetson device that's running at my house. Let's just look at what Docker's doing here. Make sure. Oh, hey, it's awake. What brand is my washing machine? That's weird. It didn't do anything. I think it'll answer this time. So you can see here, I'm running a few things. Your washing machine is an LG, blah, 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 Wi-Fi FL washer. Okay, cool. I didn't know it could answer that. What else do I have? What's the room division?
Is there a cat outside the door?
It could know that because there is also a, gosh, what is that called? There's a plugin for this that does let you run AI models against like your home network cameras and that sort of thing. And you could ask it that. So Roomba is not in use, it's charging the stock. Would you like to schedule a cleaning session? Yes.
Yeah,
Yeah,
so it's up to the,
It won't do it though.
It won't do it because it can't, like, it doesn't know how to hook the task.
Can't do it, yeah, no one's ever mapped the task a lot. It said it didn't do anything. Although one time it did freak me out because it said like that my sprinkler system needed an update and it wasn't wrong. And I don't know how it knew that. But you can also say, probably revealing a lot of information about my house here on video, but tell me about my home and it'll tell you what kind of things you have. So it just knows all that. Obviously, I'm addicted to this. I like adding things to Home Assistant. The fact that you can start to maybe control this with an LLM, and you'll see where I'm going with this. At the forefront is like a sidecar device that also controls your smart home.
So is your Home Assistant like on a Raspberry Pi, and then you have a Jetson there too?
Yeah, exactly. Exactly. It just doesn't. If I was, you could also run Home Assistant in a container on the Jetson. It probably would run better. Not a knock at the Raspberry Pi, but it is slow. So we've also got here stable diffusion. So if you want to do image generation, I know I didn't show that, but
in the future, can you attach a camera to it?
yes, there are 4 cameras attached to it.
Ask what the camera sees.
Doesn't know that. It has no idea. You need a lava or a different model for that. And I'm not saying that that's impossible, but
You'd have to like lane chain it all together. And
Yes.
be really custom.
you could do that.
Yeah.
That's why I'm saying having one of these right now is fun because there's a lot of rolling around. So it's similar. This is also running on the Jetson. We have the stable diffusion image generator. So I like to tell it, generate cartoon image of a Lhasa Apso. That's a breed of dog, for those that don't know. And you've got all these tunable parameters here where you can make it generate 6 images at a time or whatever. But think about this. At my house, I like that I have this ability. It's a cute one. But it's so wild though, the variation that it can give you. Those two kind of look similar in style, but trust me, sometimes it just blows your mind with what it comes up. Actually, does anyone want to give us a prompt that we can try? Something crazy.
Is there a way that it would recognize something from old times, not very popular? Like some character from very bad movie nobody talks about?
Yes, we could. What character are you interested in?
I don't remember.
Generate a cartoon image of Ren and Stimpy dancing.
That's oddly specific, but maybe yeah.
What does the stock chart for SPX look like for the 5 days before the next market crash?
You have to build that. It doesn't know that yet. You have to build that. It's kind of a Ren and Stimpy thing going on. Maybe we need to tune this.
That does not look like this.
Yeah.
If you gave it that specific prompt.
It
looks like it's in that style.
Yeah, it's getting closer.
generate. Let's just say
Oh,
generate an
realistic.
image.
You have to say like realistic image.
Yeah. Might give us something better there.
It's getting closer.
It's hard.
But it can do things like,
Yeah.
say, generate an image of Ninja Turtles, like that.
It clearly knows Ren and Stimpy though, like it.
Something about them, yeah. You see something on the stop here. It's funny that demo wasn't as shocking, but it definitely knows the Ninja Turtles, right? Generate a realistic image.
Well, part of that, it's always how much training data it has on a particular.
And this
word.
is all the same thing too that I showed
Yeah.
before, where you can tune this, you can add different image sets to it, you can make it learn things. So there's our. That's oddly specific. Didn't do bad. So you got that, and so you can start to see where this goes. Now, what I like, and I think is really cool, is what if you could talk to, now, for some reason, I'm just going to restart this because it never works the first time anyways, even at home. But I think this is really cool. And then I think we'll be close to concluding our demos. So we'll start off.
So that's your SSH in the Jetson.
Yeah, correct. So we'll restart this guy here.
And it's Ubuntu then on your Jetson?
Yes.
So nice.
Yeah,
It's so simple.
it is. And it over-the-air updates too for an IoT device. Like kernel updates and everything. It's pretty cool. So this should work. Hi there. Can you hear me?
Hello. Yes, I can hear you just fine. How may I assist you?
Now, how this is working, what's really interesting, it's actually talking to this. It is talking to the text generation web UI through the regular API, I believe. And you can just go back and forth with this, you know, if you want to. What I like about it too is I can change like the speaker, you know, if I want it to be a guy, or being happy. Some of these are funny. Let's actually go with that one. What do you know about the .NET user group? Never asked
Hey
it.
there. As a knowledgeable AI assistant, I've got some info on it. Net user group that might be helpful to you. The Net user group is a community of developers and of professionals who share knowledge, experiences, and best practices related to Microsoft.
So there goes the list.
Yeah.
Questions and getting answers on various topics such as speed, the net, ask the net, WPF, reform,
I'm just laughing at the phone.
The points, yeah, that's a good choice.
Net user group include one, networking opportunities.
And you can see where this is
Random
going.
tokens.
But did you notice something about this? Did you notice that this is basically real time? Like more or less? So the magic of that is it's using something called NVIDIA Reba Speech, which is an SDK that can also run on this embedded device. So we're like stringing all these things together. This is actually really fun to do too. Is watch the GPU workload when we prompt it. What should we do? It's funny, right? You're like, you can say anything that it can answer any of your questions. We don't ask it. Nobody asks it.
Can you explain how you're working inside Jetson?
Can you explain how large language models can run on an embedded device like NVIDIA Jetson? What's weird is it shouldn't notice, but it probably does. I've never asked it this specifically like this, but I've asked a similar question.
Well, it's going to infer it's a video card.
Large
Probably.
language model, like transformer-based model, can be challenging to run on resource-constrained devices like the NVIDIA Jetson. due to their time
Well, you didn't show the
requirements.
JSON.
Oh, sorry.
With some creative engineering.
Yes, you see it's this green line over here, the one that says 97%. That's it cranking. And then we can see the CPU usage and the memory is, it's using 49 gigs of memory just to produce this at this speed. There's the GPU's fully saturated, and it's done now because the text part's done, but it's still speaking. So you see that bar went down to 0. Up, right it up again.
And activations from floating point numbers to integers. This reduces the memory footprint and computational.
But it's interesting, right? Like you think about this. Now, so I started thinking to myself, like, well, it's the .NET user group, so we should probably show some .NET, right, or some C#. You can do this same thing, and there's actually an example in the docs on Microsoft Docs. It is the that's not it. Speech to speech, Azure OpenAI. So we can do the same exact demo, but using the cloud, which I'm sure you're not surprised if that works. But what I find interesting is like that worked on an embedded device, but it can also work on the cloud, which shouldn't be surprising, but how easy it is to set that up. Here we go. So there's an example here in Docs, the Azure OpenAI speech-to-speech chat, if you wanted to set this up. All you need is an OpenAI key and the name of your resource group and region. And you also have to set up a cognitive services speech thing, which has some pretty, I would say, even more robust voices that can, and you can also customize those voices. And there's just basically this big blob of code that it has here. Now, what I didn't like about this, and is my gripe about the OpenAI API, is there's a difference between chat models. Maybe there's a good reason for this, so maybe someone can talk me off of this. There's a difference between chat models and completion-based models. So if you use a chat-based model, you got to call a whole different API, not with a flag, but literally a completely different path. So yes, I am mad because it should just be a flag, but it's not a flag. And so I had to modify this demo a little bit to use it with GPT-4 because it is chat completion based. Don't worry, I did find an issue on GitHub and I gave them the sample code to adjust this for chat based, but
Completion ones are way more flexible though, at the end of the day.
but why wouldn't the API call be basically, like, I just don't feel that should have been a breaking thing, right? Like any model that's served up by this thing.
Two different tabs,
It's probably a really good answer. But the same thing here, I can run this, and this will be speaking to the Azure OpenAI instance that we showed at the beginning. Oh, we heard that.
Absolutely. Powered by OpenAI. This technology is designed for understanding and generating human-like text, making it a perfect partner for a whole spectrum of tasks. Feel free to ask your questions or share your thoughts, and I'll do my best to assist you.
Where's the best restaurants in Houston, Texas? But what blows my mind too, and this one's a little less real time. The cloud spits the result out faster, but there's the latency of it's not a local device, but it's still pretty fast. What I find really interesting about these LLMs, especially when you run them inside your house, and run them on your local network, is like they're not doing anything on the internet. They're that 49 gigs of memory that you saw is basically this entire corpus of its training text being converted into a neural network and then deciding which word to choose out of it, which is crazy.
Fans of Japanese cuisine might want to stop by Uchi Houston.
Oh, and you'll see, I told this one, like, you never respond with numbered lists, you speak like a natural person, so we're not getting the lists down here. If you're reading, sorry, probably nobody can see that, but.
The Spindletop is a revolving restaurant located on the 34th floor of the Hyatt Regency Houston.
So I didn't know
offering
that.
a
That's cool.
360-degree
But it
view
knows
of the city,
that,
along
right?
with its American-
So it's interesting stuff. So with this, I will
And
conclude,
of course,
because we're starting to blur the line here between human and computer.
Can you answer the self-aware question, like,
Known for its
how much RAM are you using to answer this problem?
Remember, these are just a handful of the many
Okay.
culinary delights that Houston has to offer. It's always a good idea to check
As soon as it
current
finishes here,
operating
yeah,
hours,
okay.
menus, and reservation
And also for
requirements
Jetson.
before you go.
How many megs of RAM are you using to generate this response?
As an artificial intelligence, I don't utilize RAM in the same way a traditional computer program does. In fact, my computation happens on powerful servers, which enable me to generate
That's a candy
responses
response.
to your questions
Think
with
so?
speed and accuracy.
Yeah, I don't think they know that because it has no actual awareness, right? It just has,
It's dynamically managed and
boy, if we
functions
crack that,
independently
that's
of
wrong.
variety.
The same with the task thing, if you had a,
Therefore, it's not
you can break out a task that can query the computer.
right, but it'd have to know, right?
they'd have to know the task.
There are some LLMs extensions that will do that, where you can like tell it to do something and it'll spit executable code out into your terminal.
Well, what is it like? What is the current weights of the neurons you're using to find this response?
It doesn't know
Absolutely.
that. Sorry. But it doesn't have that awareness, if that makes sense. It only knows. Yeah, it's not a conscious entity, I guess is the way to say it. But as we
Even as a conscious entity, you don't know the activation function of your neurons.
As we blur this, though, I'll tell you where you can get in trouble with some of this stuff. I got given this IoT device that's like used for communicating messages to somebody you might be dating who lives in another country. And in this case, I went and like reverse engineered their API and started making it send like message. You'll see on this device, like it kind of has like a screen. You can generate images with DALL-E and stuff like that. And so like I set it up to just use ChatGPT to make the responses for me. And I just want to use this as an example. See, sometimes these things aren't really a great idea. But I thought it was fun. It was a fun hacking project where you can kind of go in and reverse engineer this device. And I think the interesting part to see here is kind of at the end where you're using ChatGPT to essentially send a message to the device. Totally not authentic. Right? But anyways, so that's a kind of concludes the talk where I'd say, the promising aspects of generative AI is automating tasks that were previously not possible. Well, I'm only showing you like close enough. Like you saw with Home Assistant, like you could probably get there. Just like a little more code, we could get there. Stunning results in a short amount of time. I think in all of the demos we showed, like the results are coming at you rather quick. And if we use a smaller model, like a 7 billion input model, they're blazingly fast, almost instantaneous, but they're not as good, of course. And they're capable on embedded devices, which some people just don't believe until they see it. And I think that's like the huge takeaway here is that like you might start to see like, I don't know, it might have less people working at fast food restaurants in the future because an LLM might be there because they can run on a tiny device. Like these are the kind of thoughts I start thinking, or less people working at the Walmart, but they can still answer your questions and maybe they can look up the inventory. But they're questionable because they're not human, they're not perfect, and of course they will and they are impacting jobs. So on that note, kind of open it up for discussion.
What kind of, I'm sorry,
Go ahead.
what kind of impact do you expect,
What kind of?
impact? I mean, it's gonna impact in jobs, but.
I mean, I think one of the things I'm aware of, and that not saying that I'm aware of because I know someone's top secretly working on it, but I'm aware of just because what things I deal with in my daily life. I'm pretty sure airlines are going to be there's going to be no wait times, and you're going to be able to call up the thing that actually does help you really, really well. I think that's going to happen because to some extent, right? I also think that you're going to have product recommenders and things like that for stores that they already know, Amazon already knows what you bought. And the next thing is, you can ask it things like, will this fit inside my car? Well, what model is your car? It said this. Yes, it will fit. And you will have this many feet of room left over, stuff like that.
So, as a Microsoft employee, there's been a lot of kind of good stuff that's been coming out of Microsoft as far as training some of the smaller models. Textbooks are all you need, and there was another one that was pretty interesting. Do you see that kind of these smaller models becoming more capable and not getting much bigger?
Yeah, totally. You're going to see, and that's the question, right? Like we were talking earlier today, you're going to see Copilot assistants and that start to be baked into the Windows operating system. And the question is, are those going to run locally or are they cloud powered? I don't know. If they are running locally, what are the guardrails that are put on those things? I think we're going to definitely see that kind of thing. But what we don't know yet is how to box in the behavior plus the corpus of knowledge in such a way that we minimize these things. But the techniques we're using right now to minimize is we're throwing giant training sets at things, we're generating large models, and then we're quantizing them. But what we've not yet looked at is what is the subset of words that you need in order to accomplish this particular domain, and is that a computational problem to even determine that? Possibly. And then you get to something else that's you have to consider here too, which is different languages as well, and what kind of information just doesn't exist from one language to another for whatever reason, because there's a word that doesn't exist in one, or a particular topic is more popular in one language, so it happens to be spoken of in that language, but not in others. So can't think of a great example of that, but you get what I'm saying. There could be gaps in these things, and are they going to be truly accessible to all cultures and all people who speak all languages remains to be seen. But it's crazy though, the 7B models are pretty stunning, and they just get better and better and better. And the question is, when will those get to a point where they're solid to do big things? You're going to see it. I mean, look, if there's ever been a you see all this stuff happening, and if you wanted to say, well, I'll believe it when someone's not afraid to bake this into their operating system. Like, I think you can kind of count on that as being like, that might be the time when that question gets answered. But I don't know if it'll be powered locally or in the cloud. I just don't know.
The other thing is, like right now, it's really hard to get GPUs. Like even on Azure, if you want to provision a large amount of GPUs, it's hard.
Yeah.
And so there's a huge incentive to reduce model computation needs while not losing. And it's going to be like that for a long time because they're going to keep making supermodels, but then wanting to do lots of other things.
The reference models, you think, you mentioned that paper on the textbooks are all you need, that was using the GPT-4 to generate text, or basically textbooks style prompts for training sets.
It's insane.
So, yeah, so they were, there wasn't like a textbook on, something that existed, right? They were actually generating it based on a bunch of different subject matters and using that to train a small model.
But there's got to be some way here. Like, even if you just like, I don't know, there's got to be some heuristic here someone had to figure out. One I would just assume is like, what if you just started with every word in the English language? Is there a way to minimize this network and the connections to computationally quickly get to the next token or the next word that these algorithms do today? Because I don't really, I mean, that's kind of how they work today. But they sift through everything they've ever seen and then they create an entry. But yeah, but like, if you think about it, like if it's going to be like a, I don't know, just give a random example, like a intelligent auto mechanic, it doesn't need to know about video games, right? Like so you start to see where you can start to slice off a whole section of knowledge from these things, right? Or it doesn't need to know about cooking, it really just needs to know about that subject. And then can it generate those? Yeah, we're going to see those optimizations for sure as the specialized models come. And you're seeing that technique actually applied in GPT-4. And one of the ways that it achieves multimodality is it's not actually a single model. It's called mixture of experts. So it's like one model's good at doing this thing, one model's doing good at this thing. And it's making decisions on which one it talks to at different points in the prompt, from what I understand. So if you think about that, this mixture of experts are kind of like subset specialized models. And if we, could get our hands on building the one for flight reservations, then we would have solved that problem.
Yeah.
What are the legal issues that are coming up, especially regarding privacy and copyrights?
I'm not a lawyer, but you sure hear about that a lot, and some people certainly aren't happy about that, and you can certainly tell. I know there's been a few people who have said, like, I can tell my book was used as an input to this somehow, some way. I forgot what authors I should say.
The Game of Thrones author and like a consortium are suing OpenAI right now.
Yeah, but he's written so many books and they're so freaking long that any random string of text probably shows up somewhere.
But OpenAI or Microsoft, one of the two, said anyone who uses their products in the United States and gets sued, they will back them. Legally.
Like we just created.
Michael said that, not me. I just want to make sure on the camera
It's on
that
your-
was Michael said
Yeah, I'll look it up.
that. Who does not work at Microsoft.
Way to give your faces.
Just in case my lips,
Yeah, the AI directors, AI made movies. They're public. Well, there's
Yeah, I've seen that.
public
Those are
domain.
wild.
So then the pirate, so you can pirate it.
So-
Or, I guess pirate torrents would be.
It's called the Microsoft Copilot Copyright Commitment.
Wow.
Did you look that up on,
On
what was
Bing.
it? On Bing?
While you're waiting.
Stop saying binged it. It's never gonna happen. He binged it. Yeah.
There's one that blew my mind, 2 weeks ago. It's called, Hey Gen AI, the one that translate and makes your lips move.
Oh.
Yeah. It's amazing. It's like, you can never tell that the guy doesn't speak that language.
Oh, we have one in Microsoft where you can give it a few samples of your voice, and you can make it speak for you in other languages in that voice. And we have a guy on my team.
But with video,
No.
Video.
That's
that's the,
I was gonna say, but even on the audio side, we got a guy on my team who was born in Colombia, so he speaks Spanish, and he lives in France, so he speaks French. And I think he used the Spanish to train it, and then made it spit out the French. Then, of course, he started speaking to the user group in French, and it's like it's tonally similar. I'll just say that, like very like it sounded like him and the way he would speak French. It's pretty wild. It's amazing stuff.
I uploaded my video speaking a language. I don't know, I got a text, I don't know, about Canada. And then, it took around 4 days. I mean, the line was long. And then, I translated it into French. When I watch me speaking French, I only say oui and, like, merci, that's all. When I saw me, it was shocking because, like, it was actually me talking, and I don't know, it's unbelievable.
So someone at our office, they did it, so it did their voice. They had it call their wife and ask for their credit card number, and she gave it, but the example is used to prove, and it's happening right now, like if you get phone calls and no one's on the other end, the theory is they're recording voices now to scammers because they're going to use AI to call our family members to try and scam.
Oh yeah, that's real. Yeah, that's why I only answer the phone now. I say hi.
Hello, and that's it.
Yeah.
Don't say more than
Don't
that.
give them one syllable if I don't recognize it. Yeah.
But there's huge security problems coming up, like around the corner.
This was generator.
So I recently registered a US top-level domain. And I find out by law, you can't hide your, it was a mistake, because after that I got like 10, 20 calls every day.
Oh, if you don't register a domain privately?
No,
.us, you can't hide your domain name.
you can't hide your email, your phone number, or your.
Oh my gosh, oh wow.
So for example, Google domains, if you set up your billing with all your real phone number address,
Yeah.
as soon as you register a .us local domain, all that you can still look at. I'm still in the.
I was gonna say, that's probably why I get all these random phone, I figured it, yeah, I was the same thing about that. Where do I put my phone number? Maybe it's in a Whois database.
So never
somewhere.
register a .us domain, if you can avoid it.
Yeah, it's a lot of interesting stuff. So I just hope that folks are inspired here to realize that, like, you don't have to do all this stuff in the cloud, but you can, and you definitely should if you're working with a paying customer. You certainly should. But you can play with this stuff at home too, and there's a lot of fun things that you can do with it. And there's a lot of things people haven't done yet, and I can't wait till some people do those things for us, and then I can play with those things. And if you can't wait, build it yourself.
So one thing I thought would be kind of fun, because you can do, what is it, LoRa, that retraining for stable diffusion. It would be great to train one on just generating images of Iron Man. That way you could say,
It does it pretty good today, to be honest with you.
yeah, but you could
In the
basically,
style
like,
of Jack Kirby.
yeah, but then you can do like a Jarvis that can, like you have here, that you can talk to, and it generates an image of Iron Man. And so, could you make the gold purple, for example? And it could.
And it's just
it could
this fact that
respond
you can
with a
just
quip and an image of Iron Man.
dream this stuff. And it's like we saw earlier too. The I don't know if that's Jack Kirby's style, but okay. Yeah, no, that's not. But like with this image to video stuff, like it's not that big of a leap. Probably lots of computational power, but like that you can just be like, just generate me an episode of some Marvel Universe character doing something from some, here's the comic book series, they didn't make the movie, here, just make it for me.
That's what Disney does already.
I do
Really?
enjoy the, what is it, the cursed AI generated commercials. Those are fun.
Wait, what if we do comic book image in style? Because we were saying realistic, so maybe that's tripping it up. I just feel like we should be able to do it. That's not accurate.
It looks more like the animated.
But still, it's at home. It's just like, this one, like, I like having these things on tap at home to use my discretion. I do use I use both the one you can speak to, the Llama Speak, and I do use text generation web UI quite a bit. When you're writing emails and stuff like that.
Do those devices have GPU pins as well?
Oh, yeah. Yeah, whole embedded GPU architecture.
No, sorry, I meant, like IO pins, like,
Yes, actually, yeah, they do. There's an extension header on it, yeah, totally.
That's awesome. Yeah, so the other thing I thought would be fun, there's it's like a small embedded device. It's essentially a camera with a pre-trained chip on it, or pre-programmed chip that'll like, it'll recognize faces, it'll register when there's a face in the frame, and it will register when you're looking at it. So I thought it'd be fun to trigger listening for a device like that if you're looking at it.
That's done. That's done. Oh yeah, you can do that. That is very, very doable, if not already done. The image processing power in these devices will blow your mind. It's something like, maybe this device, I don't want to misquote, I know it can do 32 simultaneous, like RTSP streams and run 60 frames per second object detection. Actually, the previous model could do that, so this one might be able to do double.
Is that while it's listening?
Yeah. It's not like these things like, bog down, because what's great too about GPU workloads is like, it's when you kill your CPU that your kernel dies. Your GPU, you can flood it and it'll just take longer for you to get a response. But like, and that's the beauty of these things, I find. It runs like a tank, seriously. I got one running, I have another one that runs a security system all day long that's running object detection. I've been running it for 3 years now. It doesn't kick over, yeah.
That is awesome.
Yeah, I'm totally sold on it.
I've been modifying my Christmas list.
Dude, I would definitely tell you, and even if you get into the entry model ones, it's shockingly fun what you can do with them. Yeah. And it, like I said, it runs like a tank. This one almost, I got a desktop with 3080 in it, so it sings fast computer. This one does too. Like they're just as fast. You know what I'm saying? Like obviously the desktop can probably handle harder workloads, but or can it? That one's got 64 gigs of VRAM, right? Like it's weird to think about that. You got a tiny device sitting next to a big device, but they're like close in terms of power.
I would imagine you're not gonna be able to play Cyberpunk 2077.
You just made me, I was just about to say, for the classic video games and stuff, you can run your Xbox emulators, PlayStation 2.
Not that you would do that because you're on film.
No, the homebrew like code and stuff like that, and the GameCube stuff, and the Wii's. But that's what I'm saying. Like for a hobby like device that you would have at your house, not only can you play all sorts of video games on it, you can run LLMs on it, you can run computer vision models on it.
That's awesome.
Yeah, it's super cool.
So,
It's not gonna have all the instruction sets that are more specific to
Oh yeah,
like
everything.
DirectX and things, so
That-
it won't run those games.
That is the only thing,
Yeah.
and you well, years of having when you get good at it, which is cool. You learn a new skill, which is how do I port this to ARM? Yeah, everything has to be ported to ARM. Yeah, that's the big thing. But the GPU stuff's not so bad anymore. That used to be the bigger headache too. But now with things like Vulkan, some stuff tends to just work for the most part. If you're looking for GPU acceleration in whatever application, really.
It's funny too, cause like if you install like on your home PC, it's hard to use your GPU from Python, not in Docker. On a Windows machine.
Yeah,
at
yes,
least.
yeah. So yeah, it makes all those things easy, and I love too that it's the first. If you think about it, it's an NVIDIA device where they build the full scale of the hardware, you know, from the CPU to the GPU. So there's never driver issues on that version of NVIDIA running Linux. I'll leave it at that. Yeah, I've never had the GPU not flip on this device. Yeah, my desktop's a different story. Yeah, cool. Well, I think that's it for great presentation, great crowd, great conversation. Thank you all.
That was awesome.
All right. Michael, user group.
Please let me know. Thank you, Paul, for coming. Amazing as always. Improving.com. Oh, what is going on? Okay, there it goes. It's low.